linear velocity at lowermost position B in vertical circular motion. Consider a bob which is a point mass is performing a vertical circular motion. This bob is tied to the string of length r. Let B point is the lowermost position of this vertical circular motion and point A is the uppermost position in vertical circular motion. We know that the velocity at the uppermost position is given by square root of Rg and the tension at this point is always 0. The tension Ta and Mg at point A both are directed towards the center and balances centripetal force. The tension at point B, that is a TB vector, it is vertically upwards, that is towards the center and opposite to its weight Mg vector, which is directed downward direction. This is also balances a centripetal force. So in this case also, the resultant, that is the resultant of tension TB and the vector Mg is a centripetal force and it is given by Fc is equal to mvb square upon r. Let Vb be the speed at the lowermost position B. So from this vector diagram, we can write the equation as Tb minus Mg is equal to m Vb square upon r. As we know that when the bob is moving from point B to A, its potential energy increases and kinetic energy decreases. Hence, the motion along the path B to A is called as a retarded motion, whereas when the bob is moving from point A to B, its potential energy decreases and kinetic energy increases. And therefore, the motion along the path A to B is also called it as a accelerated motion. And we can calculate the potential energy along the path B to A as PE is equal to mgr minus mgr, that is equal to 2 mgr, which is also rearranged like this, mg into 2r. Hence, the corresponding change in the gravitational potential energy is converted into the kinetic energy. Hence, we can write the equation as gain in potential energy is equal to difference in kinetic energy at point B and at point A. Just substitute the value in this equation. We get the equation as mg into 2r is equal to half mvb square minus half mva square, where half mvb square is a kinetic energy at point B and half mva square is a kinetic energy at point A. So we find that half m is a common factor and we can take it out of the bracket and we write the equation as 2mrg is equal to half m into Vb square minus Va square, close the bracket here. Just substitute the value of Va, that is nothing but the square root of Rg, and just move this two terms in the denominator from right hand side to the left hand side. We get the equation as 4mRg is equal to m into the bracket Vb square minus square root of Rg. This factor is equal to Rg and we can cancel out the common term m from both hand side and we get the equation as 4Rg is equal to Vb square minus Rg. So Rg factor minus Rg factor from right hand side will move towards the left hand side and is get added and we can get the equation as Vb square is equal to 5Rg. Hence rearrange the term and we get the equation as Vb is equal to square root of 5Rg. It gives a required minimum velocity at lowest point B to travel along a vertical circle.